All right, we're going to do 5-4, the last day of graphing rational functions. So we're going to add in our last little piece. And I know the notes start right here, but I'm actually going to start, number one, you'll see is the exact same equation. So I kind of want to just start this problem and then I'll fit in, and so you can see where the new stuff kind of fits into what you already know. So the first thing you probably have found is the domain. How do you find the domain? The denominator cannot be 0. So you probably can look at that and say that the x can't be equal to 1. If you want to find other things, you probably do a factoring step. Again, some things you could maybe not factor, but I'm going to go ahead and get it factored there. And when I factor, I can see that there are no holes because there is nothing that makes the top and bottom 0. There isn't a factor that cancels. Therefore, the VA, I'm going to have a vertical asymptote at 1 because the VAs occur when the bottom is equal to 0. And then the x-intercepts, that's where I find my x-intercepts or roots is what makes the top 0. So I'm looking at those top two factors right here and seeing that I have 2 x-intercepts. The y-intercept, I plug in 0 for x. Now I could put it in the factored version. I personally think it's easier to go in this version. I just kind of cancel all those x's. Don't look at, kind of scratch out all the x's. So I'm like, oh, all those go away. So I'm left with that. And I have my intercepts. Then I get to the HA. Now you'll notice in this one, you're like, whoa, what is that HA and SA? Because we've never had this one on your homeworks. For HA, what did you do? You did Bobo-Botten. You looked at the highest powers, which again, I would probably look from the original. It's already multiplied out. Your highest powers are x squared over x. So which one is that? That's bigger on top. Bigger on top, no HA. So this is none. So what does that SA stand for? Well, if the higher power on top is bigger by 1, you will have a slant asymptote. And I want to be clear that both of these are considered in behavior asymptotes. What's happening at the ends? So you have an HA or you have an SA. Now, to be honest, there are some problems that don't have either. They're kind of not in the scope of what we do, but there is a possibility of like quadratic asymptotes as well. But nevertheless, they're in the family of in behavior asymptotes. So how do I figure this slant asymptote? Well, let me go back to this beginning. We already have the domain. We've already talked about that. Determine the in behavior of f of x. So I'm going to look at that slant, and we get to do something that I know is your favorite, and you'll be so excited that we get to use and do this again, and that is long division. So if I want to do the long division on this guy, let's see what I end up having. X goes into x, x squared, how many times? I'll get an x. I will multiply x squared minus x. Whatever your notation there is, you're subtracting. I'm going to put parentheses. If you like to make it a plus and change the sign, that's fine, whatever you do. But the x squareds will cancel. I'm doing 3x minus a negative x, which would be 4x. The 2 then gets brought down. So I do plus 4, and I repeat the process, remembering that I am subtracting, and I would get 6. Now, here's the deal. This is a little bit of explanation. I want to be very clear. My in behavior is going to do this right here. Y equals x plus 4. And to be honest, when I do that long division, I'm going to stop when I put that +4. But I want to make sure you understand, like, why can't I just ignore the remainder? Like, why can I do that? Here's why. Because if f of x, remember how we wrote that this division could be written as x plus 4 plus 6 over x minus 1. If you remember, like, doing it with numbers, that division, you have this with the remainder over the divisor. Well, remember what you're doing. You are doing the end behavior when x is a billion. When x is a billion, look at this piece right here. What happens when x is a billion? You have 6 over a billion minus 1. What does that go to? That goes away. That goes to 0. So this piece is going away, and that is also true when x is going to negative infinity. It would be negative, close to 0, but nevertheless, that's why the remainder is irrelevant. And so what I'm saying is at the ends, this function looks like that line. And of course, that is a line, right? And that's what this box is saying. This box is saying this. When will you have a slant asymptote? When the degree of the top is 1 more than the degree of the bottom. You will have that slant asymptote. Okay? So here's what I would do. If I were doing this problem, when I say there's no HA, I then look at the top and say, is it bigger by 1? Yes. And I would, had I not already done it, I would sit there, I'm not going to do it again, but I would sit there and do the long division, and I would get y equals x plus 4. So that's how it fits into what we have already done. Now, I'm hoping that when you get those things, of course, you will be able to graph, because the graphing stuff is all the same. So I'm going to put a few divots on here so you can see my stuff here. What do we got? We got an asymptote at x equals 1, a vertical asymptote. We have x-intercepts and at -1 and -2. We have a y-intercept of -2. My scale is not the best, but that's okay. And then we have the other asymptote of x plus 4. So we know that is going to be a line with a slope of 1. So it would hit here at -4. It would do like this. So that's what I have so far. Remembering that your vertical asymptote is the one that splits it into sections. So with your sections, you have 2 sections. You can probably guess how that leftmost section goes. You have dots, so go through the dots. That's going to curve there. I know those zeros are to the first power. So it's going to go through those zeros. I never can draw very well. But somewhere it's going to loop back around and then follow this asymptote there. If you're wondering, well, how do you know you didn't cross that? We'll never, remember, this is a sketch, really. We won't ask you if it crosses the slant asymptote, so I just keep it underneath. In the right-hand section, there's 2 things you should be able to figure out. I hope you know where it would be. I have 2 options. I'll put both the options down. And even before I draw that, I hope you go, oh, I know exactly which one it should be. Is it going to be on top or on bottom? Well, there's several things that can help you. Number 1, I don't have an x-intercept here. So I know I cannot hit the x-axis there. So I would know it would have to be up top. And then the second thing I could use is hopefully the vertical asymptote rules, is that my vertical asymptote is to the first power. So I know on the sides of that, I'm going to hit both that way. I'm going to hit, one's going to be down and one's going to be up. And so my graph is looking like that. All right, let's look at the next one. And that is my beautiful, lovely graph. Let's see if we can do this next one. So I hope that you will pause, maybe try to do this one on your own, and then come back. All right, here we go. I'm going to go ahead and factor everything. X and x minus 3. Okay, so there is my factoring. What's my domain? My domain is x cannot be equal to 0 or 3 because that's the denominator. I do notice that I have a factor that is repeated. So my whole is 3 comma something. Now, how do I find that something? Well, my reduced version is going to be x minus 4 times x plus 3 over x. And then I will plug in a 3 for those x's. So I'm plugging in a 3 here. 3 minus 4 is negative 1. 3 plus 3 is 6. And over 3, of course, is just 3. So I get negative 2 for the whole. Again, if you go in different order than I'm going, that's fine. I'll go ahead and do my VA is going to be x equals 0 because that would only make the denominator. So again, I call this the reduced version. So for the key is you got to do your wholes before you do your VA and your roots because you want to make sure you don't list those there. The x-intercepts, I'm going to have 2, 4, 0, and negative 3, 0. Looking at the reduced version, what makes the top 0? The y-intercept, really, I could have filled that in when I said there's a VA at 0. There's not going to be a y-intercept because you're not going to have a point there. Now for the HA, let's look at, and you can either look at the reduced version or the original, but either way, I'm going to do the reduced. The things are smaller. I have x squared over x. Do you notice that I have x squared over x as the highest powers? So I don't have an HA. Once again, I have bigger on top. The bottom, it's bigger on top, so it's no HA. It is bigger by 1, so there is a slant. So I am left with doing some long division. Now I'm going to have to multiply x squared, x minus 4 times x plus 3. I think you're with me that that would be x squared minus x minus 12. If I multiply that out, I want to go for x. Well, that'll be nice and easy. So that's going to be x there. I have x squared. That would cancel. I bring down the negative x. I really even could bring down the negative 12, but here's the deal. The second I write minus 1 and I get that constant because I know it's going to be negative x, friends, I stop doing the long division. The remainder is irrelevant. I don't even do it. I stop right there and write my slant as y equals x minus 1. So with my graph, I'm going to put my little scale in here. And I'm going to do my stuff. So I have a VA at 0. So I have that there. I have an HA at x minus 1. So that's going to look like something like this. I am going to have points at negative 1, 2, 3, and 1, 2, 3, 4. I don't have a y-intercept, but I do have a hole at 1, 2, 3, negative 2. So I have an open circle like this, and then I draw. Again, you have a VA that splits it into 2, so I hope you can see your 2 sections. You have dots that you have to go through. So this guy is going to come and follow this, and then this one's going to come follow him, go through those, and follow like that. And that is your answer. All right, so there you have it. Peace out.